Hello everyone. So a quick review of the cosine rule. Cosine rule says that one side squared is equal to the other two sides squared and added minus twice their product by the cos of the angle between them. Okay, so we're going to have a look at it today and a couple of little ones. Have some fun with it, maybe. So here's one for you to try. 7 centimeters. Let's say this is 6.8. Let's say this is 9. And we want to find A. So what do we do? Well, A is opposite 9. So they represent these two parts of the equation. They represent the B and C. Let's make it a switch and switch. Let's put them all into the formula and see what we can do. 9 squared is equal to 7 squared plus 6.8 squared minus 2 times 7 by 6.8 by the cos of A. So I just need to get A. So you can see what you're dealing with here is when you bring these two over, that's just a subtraction. Then you're dividing across by a negative, and then you're inversing the answer. So if you wanted to do it all in one go, then A was going to be equal to the cos inverse of 9 squared minus 7 squared plus 6.8 squared divided by negative 2 times 7 by 6.8 in one fell swoop, just to kind of give yourself a little bit of a break. You can do it in stages if you want, but you should be well able at this stage to be able to do it in one group. 9 squared minus 7 squared plus 6.8 squared over minus 2 bracket 7 6.8 close the bracket 81.39 degrees. There you go. Nice one, just to start, just to kind of get yourself into the flow of this. Okay, we'll try another one. Right. I love these ones. These ones are like so cool. Anyway, so here's our scenario. Here's the ground, and then there's a little bit of a hill. Okay, and on the hill, there's a pole. So there's a pole on the hill. There's the hill. There's the pole at the top of the hill. Okay, now let's try and find out the height of the pole. And let's say this is the wire holding up the pole. Okay, so I want the height of the pole and the length of the wire. And then we'll throw in some numbers to help us. Okay, let's say that's 12 degrees. Okay, and let's say that the hill itself is at an angle of 8 degrees. So that's all we've kind of got going for us. Okay, let's see, is there anything else we can give you? Yeah, let's say that the distance in a different color. Let's say the distance between there and there. So that pink line, let's say that that distance is 20 meters. So we need the height of the pole. Okay. Right. So we haven't got much information to kind of go on, do we really, when you think about it? So we need something else to kind of help us out. In other words, to kind of figure out what we're going on. There is a couple of things we can do. Okay. We need to kind of put in more information. If we don't put in more information, we can't generate some more answers. So let's try and put in more information, because the more you can put in here, the better it's going to be. Okay. It would be handy if we could find one of those angles. Okay. So the only thing I know for sure is that this is a flat line. This is the ground. Okay. As in, you know, sea level ground. I know that's the ground there, but it's on a hill. So there's 8 degrees between there and there. So if you were to imagine this, you can move the ground up and redraw it at the base of the wire that's holding it up, so that these are parallel. So this is an imaginary line I've drawn. But if that's an imaginary line, that makes this 8 degrees in here as well. Okay, corresponding angles. You just moved it up, so still corresponding. So now that gives me 20. And if I still move it even further up, okay, so let's keep going right up to here, okay, and draw it parallel with the top. Well, there is a line, that green wire is joining two parallel lines. So if that's 20, 12 plus 8, then this is 20 out here. So now I've actually got a bit more information going for me. Okay, so now that I have that information going for me, it's now a matter of just trying to figure out something else about it, for want of a better word. If that's parallel and that's straight up and down, well, then that has to be 70. Okay? You get it? Because straight up and down. If that had extended right down to the ground, it would be perpendicular. So that's 70. So now do I have enough information to do something at least? What I do, I have opposites to help me now. So I can do a sine rule to get h. So let's see, 20 over the sine of 70 degrees is equal to h over the sine of 12 degrees. God, this is a tough one. So let's get h. H is going to be 20 sine 12 over sine 50. 20 by the sine of 12 divided by the sine of 50. Sorry, sine of 70. 4.42. Okay? Now, how does that help us with the wire? It doesn't, because I can't. I could figure out that one to get the wire and use opposites. I could now, but let's do the cost rule on that one. Okay, so now I have the angle 12 and what's that? 12 and is going to be 98, isn't it? 89 and 98. That's 98 degrees. So could say wire over that would be that. I can do sine rule again, but let's for the crack of it. Wire squared is going to be equal to 4.42 squared plus 20 squared minus 2 times 4.42 by 20 by the cos of 98. Just for the crack. Okay, probably could have done the sine rule, but listen, life's too short to do it the cool way. So square root of 4.42, sorry, 2 squared plus 20 squared minus 2 bracket 4.42 times 20 times the cos of 98 equals 21.07. The wire is 21.07. Now that's a tough one. You know, that is like epic. Okay, epically tough. But that's probably, you know, there's a lot of stuff you're having to get into there. There's a lot of geometry. There's a lot of maybe even using the sine to get to the cosine or using the cosine to get back to the sine. So don't be afraid to mix and match these things when you need to use them. Okay, it's a pretty tough one. Fair enough. Right. Okay. Listen, we leave it at that.